Acids and alkalis only show their true chemical personalities in water. The moment they dissolve, their molecules break apart into ions, and these ions are what give them their familiar properties. Acids release hydronium ions, alkalis release hydroxyl ions. These charged particles are responsible for reactions like neutralization, conductivity, and even corrosion in metals. A hydrogen ion, or proton, is tiny and extremely reactive, far too unstable to exist alone in water. Instead, it quickly attaches itself to a water molecule, forming a hydronium ion with the formula H3O+. This ion is the true carrier of all acidic properties in an aqueous solution. Without hydronium ions, acids would have no taste, no conductivity, and no reactivity with metals or bases. Let's take hydrochloric acid as an example. When HCl dissolves in water, the hydrogen ion leaves the chloride ion and bonds with a water molecule. The result is a hydronium ion and a chloride ion. We can write this as hydrogen chloride plus water gives hydronium ion plus chloride ion. Strong acids like HCl ionize completely, while weak acids like acetic acid only do so partially. For alkalis, sodium hydroxide is a perfect example. When NaOH dissolves in water, its ionic lattice breaks apart, releasing sodium ions and hydroxyl ions. It's the hydroxyl ion that makes the solution basic. It can neutralize hydronium ions and turns red litmus paper blue. Potassium hydroxide, calcium hydroxide, and ammonium hydroxide follow the same basic principle. The real magic happens when hydronium ions meet hydroxyl ions. They combine to form water, cancelling each other's properties in the process. For example, hydronium ion plus hydroxyl ion gives two molecules of water. The other ions present form a salt. This is the basis of neutralization reactions, whether in a laboratory titration or in an antacid tablet relieving stomach acidity. Understanding ion formation is the key to understanding acid-base chemistry. It explains why acids and alkalis conduct electricity, why some are strong and others weak, and how we can calculate their pH. It also underpins real-world applications from electroplating and chemical manufacturing to environmental processes like treating acidic wastewater. Let's quickly recap what we've learned. First, acids and alkalis only exhibit their true chemical properties when dissolved in water. Second, acids form hydronium ions, that's H3O+, by combining hydrogen ions with water molecules. Third, alkalis produce hydroxyl ions, OH-, when they dissociate in water. Fourth, neutralization happens when hydronium and hydroxyl ions react to form water and a salt. And finally, the ability of these substances to form ions determines their strength, their conductivity, and their many applications in laboratories and industries.